Hi students, this is your algebra video on substitution and elimination for systems of equations, and I am on page 5 in your new purple packet for Unit 8. And we are going to talk about two different algebraic methods for solving a system of equations. Last class you learned how to graphically solve a system of equations, and so now we're going to move on to algebraic ways to solve a system of equations. And there are two ways to do this. They are called substitution and elimination. And hopefully those sound familiar because you did learn these in middle school. If the names don't sound familiar, hopefully the methods will look familiar as we do them. Okay, so we're going to start with substitution. Again, I'm on page 5 in your packet. And the idea behind substitution is to substitute an expression for a variable. Okay, in order to substitute, you need to have a variable alone. Okay, so it's always important to have a variable alone. Need to have a variable alone. You cannot substitute without this happening. Okay, so if you look at the system that's given to us here, there is not a variable alone. Now the x does not have a coefficient, but when I say alone, I mean by itself on that side of the equation. So on the bottom, the y does not have a coefficient, but it's also not alone on that side of the equation. So you're just going to choose a variable to get by itself in one of these equations, and if one of them does not have a coefficient, that's the best one to go with. So I'm going to go ahead and take this top equation. This can be done with the bottom. I'm just going to go ahead and use the top equation, and I'm going to solve this for x, okay, so that it will say x equals. So pretty simply here, we're just going to add 5y to both sides. Okay, so that moves the 5y where we have x alone, so x equals, and since these are not like terms, we're going to just call it 5y plus 10. Okay, once you have a variable by itself, you are able to substitute this expression 5y plus 10 for that variable x into the other equation in the system. So notice I circled my top equation because I already used it. So for step 2, we're going to take the other equation, okay, so that's the bottom equation, negative 2x plus y equals 7. And we're going to replace x with its equivalent expression. So we're going to take out the variable that I circled here, and we're going to fill in 5y plus 10. So I like to circle that here because then now I see what I'm replacing. The whole rest of the equation has to stay the same. So the negative 2 has to stay. The x has to be replaced with an expression which is going to have to be put in parentheses. So this expression is going to be 5y plus 10. Okay, so I took my expression from here and substituted it for x down here. Now, after the x, I have the rest of the equation staying the same. So plus y equals 7. That's going to stay the same. Okay, so notice the only thing that changed about this equation is what this, I circled the x, replaced it with the expression, and everything else is the same. So now we solve this equation for y. So we're going to go back to our equation solving skills from earlier in the year, and we've been using them all year. We're going to distribute, so negative 10y minus 20 plus y equals 7. And we're going to continue into the step 3 box here to solve for y. So we're going to put together the y's. Negative 10y plus y is negative 9y minus 20 equals 7. And hopefully you're getting much better here or are very good at solving a 2-step equation. So negative 9y is equal to 27. And when I divide by negative 9, I get an answer of negative 3 for y. Okay, so once you get the substitution part over with, it's just a regular equation like you've been solving for years. Okay, now this is a system of equations. Sorry, I'm going to scooch back up to the top here. In a system of equations, we have 2 variables, and so we have to have an answer for both variables. So back down to what we found that y is equal to negative 3, and I do like to kind of put a little star next to it so I don't forget that I found one solution, but I'm not done. I need to find the other solution. So I'm going to plug this value back into one of the original equations to get the other coordinates. So you're going to look back at the top of the page and pick an original equation. It does not matter which one. I'm going to choose the top equation. And since I know that y is negative 3, I'm going to plug that in. So x minus 5 times negative 3 is equal to 10. We multiply to get 15, so x plus 15 is 10, and we get x alone. So x is negative 5. Okay, so now I have found my two solutions. If you have two variables, you do need a solution that contains both variables. More often than not, because of x and y, we write this as an ordered pair. So I always want you to say solution, just like we did when we were graphing, and then give me the ordered pair. And the ordered pair here is negative 5, negative 3. And does the order of that matter? Absolutely. You have to give the x coordinate first and the y coordinate second. And that's how you solve a system by substitution. So the paper that I gave you in class has an example on it for substitution. So if you want to, you can pause the video and do that now. Or you can keep watching the rest of the video and then do both of the examples at the end. Okay? I'm going to switch to page 13 in my packet. Okay, kind of zooming forward a little bit here. Page 13 has elimination, okay? And elimination is what it sounds like. We are going to eliminate a variable. And so in the last example, we substituted for a variable. Now we're just going to eliminate a variable altogether. This is going to require these two equations to work together, okay? And we're going to do this through addition or subtraction. But first, you cannot do this without lining up your columns of x's, y's, and constant numbers. So even though my x's and y's are lined up, my equal sign is not in the right place. The x's and y's need to be on the same side. So I'm going to take my bottom equation and I'm going to just get it so that the x and the y are on the same side. So I'm going to minus the 2y over to this side, okay? No like terms, so we're going to bring them both down. We're going to put this in what we call standard form, so 5x minus 2y equals 1. Standard form of a linear equation is ax plus by equals c. And for elimination, you need to have both of your equations in that form. Okay, so now I'm going to go ahead and take my top equation, which already was in standard form, and my bottom equation, which I put in standard form, and I'm going to decide how to eliminate a variable. And you're either going to do this by adding or subtracting down each of the columns, okay? So if I added these two columns together, would either of my variables be eliminated, so canceled out? So if I do 5x plus 5x, I would get 10x, so that does not cancel out. If I do 3y minus 2y, I get 1y, and that does not cancel out. So I cannot do addition because I will not cancel a variable. Can I do subtraction? So if I do 5x minus 5x, I get 0x, and 0 times x is 0, and so I have canceled my x variable. So subtraction is going to work here for eliminating x. The way I like to do this is to show the subtraction the whole way through. So I'm subtracting the 5x. Now if I'm subtracting negative 2y, I'm actually just adding 2y because two negatives make a positive, and I'm going to subtract 1. So I carry that through the whole bottom line. So I'm basically changing all of the signs on the bottom. And then that way it won't make me forget. I won't forget while I'm working that I was supposed to be subtracting because now I've already set it up. Okay, so we're going to go column by column. Our first column, these add up to 0x. So in other words, it all cancels out. I have 3y and now plus 2y because I changed it. So I have 5y equals, and I have 11 minus 1 because I changed that to a minus. And 11 minus 1 is 10. Now you're going to go ahead and solve for the variable that's left. So 5y equals 10. The good news here is it's always an easy one. Divide by 5 and y is 2. I have found my first solution. And the last step is actually the same as the last method, which is to substitute the 2 for y into an original equation. So back up to the top, I'm going to choose 5x plus 3y equals 11. And I'm going to fill in the 2 for y. So 5x plus 3 times 2 equals 11. And I can now solve this equation because 3 times 2 is 6. And I can subtract 6 on both sides. So that 5x is equal to 10. Nope, that's wrong, sorry. 5x is equal to 5. Got to make sure you subtract correctly. Divide both sides by 5 so that x is equal to 1. Okay, so there's your second solution. And then the final thing you're going to do is you're going to write the word solution and give me the coordinates of the point that are a solution, which is 1, 2. And there you have it. So that you have, on the paper that I gave you in class, you have a second example that has elimination on it, and you can go ahead and try that one on your own. So now that I've given you notes on the two methods, use the notes on these and the notes on the paper I gave you in class to help you solve the two equations on the paper. All right, I hope you're having a good weekend, and I will see you in class.